So if we measure a number in a calculation, then the calculated results should reflect the precision of the data. And this is shown in the significant figures of your final calculate number. So for calculations involve multiple steps, keeping in mind that we only round in the very, very last step. Do not round off between steps. Otherwise, this will, if you round between steps, it will potentially cause rounding errors that eventually affecting the final answer. So rules for rounding off. If the first digit to be dropped is 4 or less, then it and all the following digits are simply dropped from the number. Okay, so for example, let's say that if we want to round 2.334 to two significant figures, okay? So the first one to be dropped is 3, all right? And then since it's less than 5, all right? So we'll simply drop that and the rest of the digit, okay? So if the first digit is to be dropped is 5 or greater, then the last retained digit is increased by 1. So for example, in this number, 2.37, so we want to run that to two significant figures. Start with 2, and we're keeping 2 and 3, and we'll drop 7. 7 is the first one to be dropped. It's a little greater than 5, so the 3, the last retained digit, is going to increase by 1. That should be around to 2.4. Keeping in mind the rounding off numbers to correct significance, the goal is to show the accuracy or the precision of the number. You will not change the size of the number significantly. 2.334, 2.3, they're not that much different. The only difference is how precise, how accurate the number is. Now, if we look at 8.4234 here, let's say if we want to drop to 3 significant figures, right? So we'll keep 8, keep 4, keep 2. The first digit that will be dropped is 3. Since it's less than 5, so we're just going to drop it and the rest of the digits. So it's 8.42, okay? Now, let's look at 3256, this number. Now, if we want to drop it, around this number to 3 significant figures, right? We're keeping 3, we're keeping 2, and we're keeping 5. Okay, so we're 6 is the first digit to be dropped. Since 6 is greater than 5, so we round it up. It becomes 3, 2, 6. Is this right? So we're converting 3,256 to 326. This is not right because the size of the number has changed significantly. Let's say you were supposed to get paid for $3,256 and your boss decided to round it up and he rounded to 326. You wouldn't be happy, right? Because when we dropped 6, this we need to add 0 as a placeholder to ensure the size of the number. This scenario only applies to the relatively large number without the decimals. All right. So the correct 3 significant figures for this number is 3,260. Or you can use scientific notation as 3.26 times 10 to the power of 3. Okay, so the value of a large number is retained by using placeholder zeros to replace drop digits, so we don't change the size of the number significantly.